Okay, so we've dealt with when given the roots generating a cubic, or when given the curve generating a cubic. Now I want to talk to you about when given the cubic equation, how do you find the roots? Remember that when we do that with quadratics by factorising the quadratics and simply letting each factor equal to 0 and identifying the roots. However, we can't factorise a cubic like this. In order to find the 3 roots of a cubic, the first thing that we do is we simply use trial and error. So what we're going to do is we're just literally going to use trial and error to identify our first root. Logically, the first thing we should always investigate is x equals 1. Sub in 1, and if everything cancels out and you're left with 0 equals 0, that will tell you that x equals 1 is a root. If that doesn't work, we're then going to move on and we're going to try x equals minus 1 and see if that works. If that doesn't work, we're going to move on and try x equals 2. And if that one doesn't work, we're going to try minus 2, and then 3, and then minus 3, and so on. So let's just work through this. I have a cubic x cubed plus 3x squared minus 46x minus 48 equals 0. If x equals 1 is a root, when I sub in 1, everything should cancel out. So I'll get 1 cubed plus 3 times 1 squared minus 46 times 1 minus 48 equals 0. In this case, 1 cubed is 1, 3 by 1 squared is 3, minus 46 minus 48 equals 0. You can probably tell already that this one is simply not going to work out. Here I have 1 plus 3, which is 4, minus 46, so those 3 add up to minus 42, and this is a minus 48 equals 0. So ultimately there I end up with minus 90 equals 0. So that one is no good to me. That tells me that x equals 1 is not a root. So then we're going to move on and try minus 1. If I sub in minus 1, I'm going to get minus 1 cubed plus 3 times minus 1 squared minus 46 times minus 1 minus 48 equals 0. If I have 3 minuses, I end up with minus 1. Minus by minus gives me plus, so this is 3 times 1, which is 3. Minus by minus is plus, so that's a plus 46. Minus 48 equals 0. Here I have 3 plus 46, which is 49. I have minus 1 minus 48, which is minus 49 equals 0. So I'm happy enough with this one. I'd finish this off by saying that 0 equals 0. So that one is true. And by now I can conclude that x equals minus 1 is a root. Remember from previous videos that if you have a root, you can come up with a factor. If x equals minus 1 is a root, I can now conclude that x plus 1 is a factor. Once I have one of the factors of my cubic, it is relatively straightforward now for us to find the other factors and ultimately then the other roots. So one of the roots I've identified is x equals minus 1. Let's discuss now how I would work from there using x plus 1 as a factor. Okay, so now I want you to think about factors. For example, let's just think about it. 3 multiplied by 4, they are factors of 12. 3 and 4 are factors of 12. But I want you to think about this differently now. If I give you one of the factors, if I told you that 3 is one of the factors of 12, how would you get the other factor? If you know one factor, in order to get the other factor, you use long division or you just divide it in. So I get the other factor. So if you know one of the factors of the cubic, you simply use long division to find the other factors. From what I did in the previous part, I've identified that x plus 1 is a factor of the cubic. So I'm going to use long division, and this is going to be the same as the way we did long division at junior cert. I'm simply going to divide the factor I know into this cubic, and that's going to give me a quadratic on the top, which I can factorize and solve to get the other 2 roots of my cubic. Now, over the next few videos, we're going to be talking a lot about long division, and in my mind, the questions we do in long division are going to be the most difficult questions that come up in algebra. So I'm going to really drag it out here. You need to be really, really comfortable with your long division. There are a couple of different ways of doing long division. The way that I'm going to show you now is the easiest way to do the really, really difficult questions that we're going to move on to. So I'm just going to remind you of long division at junior cert level. If I'm dividing x plus 1 into this, there are 4 steps to long division. The first thing I would do is I would divide. So step number 1 is always to divide. So you should divide the first thing here into the first thing here. X divided into x cubed will give me x squared. The second step in our long division is that we need to multiply. So I'm going to multiply the thing that I put on the top by these two things. X squared by x gives me x cubed. X squared by 1 just gives me 1x squared. Now the third step in our long division is we need to subtract. And in order to subtract, you have to change your signs. So if this was a plus x cubed, it's going to become a minus x cubed. If this was a plus x squared, it's going to become a minus x squared. I always tell my students to do it like that, change the sign and circle it, because otherwise you end up with a plus and a minus in front of everything and it gets really confusing. So x cubed minus x cubed cancel out. 3x squared minus 1x squared gives me 2x squared. And the fourth step, and the fourth and final step in our long division, is you just take down the next term. In this case, the next term I need to take down is the minus 46x. Once I've followed my 4 steps, I just start the process all over again. The first step in long division is to divide. So I'm going to divide the first thing here into the first thing here. X into 2x squared goes plus 2x times. The second step in long division is you multiply. So you take whatever you had up here and you multiply by each of these. So 2x multiplied by x gives me 2x squared, while 2x multiplied by 1 just gives me 2x. The third step in long division is that you need to subtract. So I draw a line underneath and I change the signs of each of these. This was a plus 2x squared, it becomes a minus. This is a plus 2x, so it becomes a minus. Now I have 2x squared minus 2x squared, which will cancel. I have minus 46x minus 2x, which is minus 48x. And now I'm at step number 4 in my long division, which is to take down the next term. The term I'm going to take down is the last one, and it's a minus 48. And now I'm just going to start the process all over again. I need to divide the first thing here into the first thing here. X into minus 48x is going to give me minus 48. The second step is multiply. So I'm going to multiply the thing on the top here by each of these. Minus 48 multiplied by x gives me minus 48x. Minus 48 multiplied by 1 gives me just minus 48. The third step is we need to change our signs. So the minus 48x becomes a plus and the minus 48 becomes a plus. Now I have minus 48x plus 48x, which is 0. I have minus 48 plus 48, which is 0. And I'm left with a remainder of 0. So we've done two things there. One thing we've done, because x plus 1 divides into this cubic and I get a remainder of 0, we've verified the fact that x plus 1 is a factor of this cubic. Basically, we've just reiterated what we said in the very first part of this question. But also, I've divided one factor into the cubic, which means I've found the other factor. I now know that if I multiplied x plus 1 by x squared plus 2x minus 48, I would have the cubic here. So the factors of this cubic are x plus 1 times this quadratic. The original question here was to solve this cubic. If you need to solve a cubic, you need to find the 3 roots. So what I'm going to do now is I'm going to factorize this quadratic. I'm going to then have 3 different factors. I'm going to let each factor equal to 0 and come up with the 3 roots. So I used trial and error to identify that one of my factors is x plus 1. I then used long division to prove that the other factor is x squared plus 2x minus 48. The goal here is to find the 3 roots of the cubic. So I'll start off by just an x plus 1 and I'll leave that where it is. I now need to factorize this quadratic. The factors of x squared plus 2x minus 48 are x plus 8 times x minus 6. And then just like if we were when we factorize and solve quadratics, I just now need to let each factor equal to 0 and I'll get my 3 roots. So the one that we actually already had was that x equals minus 1. However, I always tell students just do it again. The very last thing you should do is write out your 3 roots of your cubic. I can say that x plus 8 equals 0, which means another root is x equals minus 8. And I can say that x minus 6 equals 0, which tells me another root is x is equal to plus 6. So the 3 roots of this cubic are x equals minus 1, x equals minus 8, and x equals 6. So you'll notice that in this video, all we're doing is solving cubics. You're not actually doing any new material. Everything I'm after doing in this example is actually just from Junior Cert Algebra. It's just a longer question and you really need to understand what's going on. So I'm going to give you a couple of questions now, and in each case I want you to solve the cubics. Okay, so to practice that, I want you to solve these 3 cubics. In each case, you're going to have to use trial and error first in order to identify a root. When you've one of the roots, you convert that root into a factor. And when you have your factor, you use long division to find the other factor. So, and then ultimately for these 3 cubics, you should be able to find the 3 roots of each cubic. So I want you to pause the video now and try this yourself, and then compare it to my solutions. The first question here, I asked you to solve the cubic 2x cubed plus x squared minus 13x plus 6 equals 0. In order to find the first root, you need to use trial and error. So I started with x equals 1, I subbed in x equals 1, and I ended up with minus 4 is equal to 0, which clearly isn't true. So if x equals 1 doesn't work, you'll then try x equals minus 1. When I subbed in x equals minus 1, I ended up with 18 equals 0, which obviously isn't true either. So now I'm going to move on and I'm going to investigate if x equals 2 is a root. So I've moved on now to investigate if x equals 2 is a root. If you sub in x equals 2, you end up with 26 minus 26 equals 0, or in other words 0 equals 0. So this one works out, means I can conclude that x equals 2 is a root. And if x equals 2 is a root, remember I'm not concerned with the roots for the moment, I want the corresponding factor. So I subtract 2 from both sides and I can conclude that x minus 2 equals 0 is a factor. If I know one of the factors, I can divide the factor into the cubic and I can come up with the other factor. So now that I have one of my factors, I'm going to divide it into the cubic to find the other factor. And I have my 4 steps for long division written out here. So the first thing I'm going to do is divide. I'm going to divide x into 2x cubed and it's going to give me 2x squared. Now I'm going to multiply the thing on the top by each of these. 2x squared by x is 2x cubed, while 2x squared by minus 2 is minus 4x squared. My third step is to subtract, so I'm going to change each of those signs. Plus 2x cubed becomes minus 2x cubed, minus 4x squared becomes plus 4x squared. The x cubed will cancel out, and I have 1x squared plus 4x squared, which gives me 5x squared. And then my fourth step is I need to take down the next term, which is a minus 13x. And now I'm just going to start my process all over again. I'm going to divide x into 5x squared and it gives me 5x. And then I'm going to multiply 5x by each of these. 5x by x is 5x squared, while 5x by minus 2 is minus 10x. My third step is I need to change my signs. So this is going to become a minus 5x squared and a plus 10x. The x squareds will cancel and I have minus 13x plus 10x, which gives me minus 3x. My fourth step then is to take down the next term, which in this case is a plus 6. And I'll start my process one more time. I'll divide the first thing here into the first thing here. X into minus 3x gives me minus 3. I then multiply minus 3 by each of these. Minus 3 by x is minus 3x, while minus 3 by minus 2 gives me plus 6. I'll then change my signs, so I'll get a plus 3x and a minus 6. The x's will cancel and the numbers will cancel and I'm left with 0. So I've now used the factor that I found by trial and error to generate the other factor. I know that x minus 2 multiplied by 2x squared plus 5x minus 3 will give me the original cubic. And I can use that in order to come up with the roots of the cubic. So I started off with this is my original cubic. I've worked out now that x minus 2 times this quadratic will give me the original cubic. So what I did then was I factorized my quadratic and I got 2x minus 1 times x plus 3. I now have 3 factors of the original cubic. So I can just let each factor equal to 0 and I can solve and get my 3 roots. And the 3 roots in this case ended up as x equals minus 3, x equals a half and x equals 2. Okay, in the second question here, we have the cubic x cubed minus 4x squared minus x minus 4 equals 0. In order to find the first root, we need to use trial and error. So as always, we start off with x equals 1. When I subbed in x equals 1, I ended up with 0 equals 0. That tells me that x equals 1 is a root, and I then convert that to the corresponding factor, I can conclude that x minus 1 equals 0 is a factor. And now that I have a factor, I'm going to use a long division to divide my x minus 1 into my original cubic to find the other factor. So I've carried out my long division here. I've divided x minus 1, the factor I've identified, into the cubic. And my answer was x squared minus 3x minus 4. Just remember that by dividing x minus 1 into the cubic, if my remainder is 0, I have verified that x minus 1 is a factor, or in other words, that x equals 1 is a root. Now that I have this quadratic and I have this factor, I can work out the roots of my cubic. So I've identified that x minus 1 times x squared minus 3x minus 4 will give me this cubic. If I factorise this bit that's a quadratic, I get x minus 4 times x plus 1. And if I let each factor equal to 0, and then I isolate my x, I get my three roots are x equals 1, x equals 4, and x equals minus 1. In the third one, we had to solve 2x cubed plus 7x squared plus 7x plus 2 equals 0. As always, we're going to use trial and error to try and find the first root. Logically, the first one that we'll try is x equals 1. In order to investigate if x equals 1 is a root, you sub in, everywhere there's an x in the original function, you sub in a 1 and hopefully everything cancels out. But when I subbed in x equals 1, I ended up with 18 equals 0, which it clearly isn't. So in that case, I know that x equals 1 is not a root. Once x equals 1 hasn't worked, you then move on to x equals minus 1. So what I've taken my original function, except everywhere there was an x, I subbed in a minus 1. And when I did that, everything cancelled out, I ended up with 0 equals 0. That tells me that x equals minus 1 is a root. Now imagine what would happen if you added 1 to both sides in this case, you would get the corresponding factor. So this tells me that x plus 1 is a factor of this cubic. And I know that if I divide x plus 1 into the cubic, there will be a remainder of 0, but it will divide in, and on top of it I'll get a quadratic. If I factorise and solve that quadratic, I'll find the other two roots of this cubic. So I've divided x plus 1 into the original cubic, and I got a remainder of 0 and a corresponding factor of 2x squared plus 5x plus 2. And this is going to allow me to identify the other two roots of the cubic. So I now know that x plus 1 times this quadratic will give me the cubic. So if I factorise the quadratic I've found, I get 2x plus 1 times x plus 2. The three factors of the original cubic are here. I let each factor equal to 0 and isolate x, and I get the three roots are x equals minus 1, x equals minus a half, and x equals minus 2.